Today we are explaining AgentOPSD, a method for assigning credit to the turns that actually determine whether a long horizon agent succeeds.
What is the central problem this paper is trying to solve?
In a multi-turn task, a final success or failure is usually broadcast to every token in the whole trajectory. That is simple, but it cannot tell which decision was pivotal. AgentOPSD turns dense teacher student signals into turn-level credit and then keeps updating that credit as the interaction unfolds.
Why is the usual group relative reinforcement learning signal not enough?
GARPO computes the sequence-level advantage from the reward of each sampled trajectory relative to its group. Every token in that trajectory receives the same value. Earlier self-distillation methods add local teacher-student contrast, but a local contrast can be redundant after earlier turns have already established strong evidence for the outcome.
What does AgentOPSD change in the training signal?
It uses a privileged skill only during training to compare the probability of the generated action with and without success-related information. The token gaps are summed within a turn, so the evidence matches an environment interaction rather than an arbitrary token boundary. The key design is recursive belief tracking. The initial belief is the group's success rate. Each new turn adds evidence to a decaying log odds accumulator, and the useful credit is the change in belief from one turn to the next.
Why master a belief revision instead of using the local gap directly?
Because the same evidence can matter at one point and become redundant later. The revision is large when the current belief is uncertain and the new evidence changes it, but it is suppressed when accumulated evidence has already pushed the belief towards saturation. Its sign is also retained, so the update can distinguish evidence consistent with the final verifier outcome from evidence that conflicts with it. This equation defines the recursive belief used by AgentOPSD. B0 starts from the clipped group success rate, CK carries decayed evidence, and the sigmoid maps log odds back to a belief between 0 and 1.
So what does the final advantage given to a turn look like?
AgentOPSD standardizes the turn revisions within each trajectory and uses a bounded multiplier to reshape the original sequence advantage. The multiplier changes magnitude without reversing the policy update direction, and the lambda parameter controls how strongly turn-level credit is applied. The method diagram puts the whole contrast in one view. The agent produces a sequence of turns. AgentOPSD aggregates token gaps, tracks the belief revisions, and assigns different advantages to different turns. Vanilla GARPO instead broadcasts one sequence advantage to every token.
In that comparison, what is the concrete difference between the middle and right panels?
The right panel assigns identical credit across the trajectory. The middle panel preserves the same policy optimization backbone, but lets each turn inherit a weight based on how much that turn revises the success belief. This is the paper's proposed mechanism, not a new rollout or a second critic.
How broad is the evaluation?
They train QN to 0.5 models at 3 billion and 7 billion parameters on ALF World, Webshop, and Search QA. The comparisons include vanilla models, GARPO, and several skill-guided or self-distillation baselines under a shared setup. The main comparison shows AgentOPSD at or near the top across the three environments and both model scales. On ALF World with QN to 0.57b, it reaches 89.1% success. The paper's controlled comparisons attribute the gain to how credit is constructed, rather than simply to access to privileged skills.
Does the advantage become more important when the interaction lasts longer?
Yes. As the number of turns grows, uniform credit methods lose performance faster. The paper reports the flattest degradation for AgentOPSD on ALF World, consistent with the idea that history-dependent revisions matter more when a trajectory contains more decisions.
Which parts of the method are responsible for the 89.1% result?
The ablation starts at 89.1% for the full method. Replacing turn-level accumulation with token-level accumulation lowers it to 85.9. Using the raw local gap instead of recursive revision lowers it to 80 to 0.8. Dropping the sign direction gives 80.5, and removing the group-based prior gives 78.9.
What do those drops tell us about the mechanism?
They separate three roles. Turn-level grouping keeps one environment action together. Recursive revision removes evidence that has become redundant. Sign direction aligns the credit with the final outcome, while the prior anchors the initial belief to the group's observed success rate. Removing each ingredient damages a different part of the result. The training objective keeps the clipped policy optimization form, but substitutes the reshaped advantage for the original sequence level value. The extra cost is one teacher forward pass per trajectory. The belief update itself adds no rollouts and no learned parameters.
What is the paper's main conclusion?
AgentOPSD makes sparse outcome supervision useful at the level where an agent actually acts. Its teacher-student contrast supplies evidence. Recursive Bayesian tracking decides whether that evidence is still pivotal. Unbounded reshaping turns the result into a safe policy optimization weight. Across the reported environments, the evidence supports turn-level, history-dependent credit over uniform broadcasting.
So the important result is not just a higher score, it is evidence that the credit signal should follow the interaction history.
Exactly.